are going to be looking at the experiment molar mass of a volatile liquid. So for our procedure, for the molar mass of a volatile liquid, we need to determine the volume of our Erlenmeyer flask. To do that, we are going to fill it with water. So we know it's more than 100 milliliters. Refill our graduated cylinder to the 100 milliliter mark. And we're going to add as much water as we can to completely fill our flask to the brim. We're going to carefully add this. As our gas will take up the entire volume of the flask, we need to fill our flask all the way to the brim and record our volume on the graduated cylinder. Once you have that recorded, we're going to empty the flask, and because it's wet now, we do need to dry it in flame. So we're going to turn the gas on, light our Bunsen burner, and then for safety we're going to use flask tongs in order to hold on to it. So we're going to heat it until all of the water has been removed from the flask, and at that point we're going to let it cool down again before we give the weight. So we've set up a beaker, 800 milliliter beaker in the hood with about 200 milliliters of water and a few boiling chips. We're going to heat this now so that it will warm up the liquid inside our Erlenmeyer flask. Now that our flask is dry and cool, we're going to weigh it on the analytical balances along with the aluminum wire and the aluminum foil. So before you start, you'll make sure all the doors are shut and the scale reads 0. We're going to add our aluminum foil, and remember we want to handle the flask with a CHEM wipe so we don't get fingerprints on it. Okay. We're going to record that mass for the mass of our empty flask. We are now going to add half of our unknown into our Erlenmeyer flask to determine its molar mass. We're going to put the smallest piece of aluminum foil that we weighed on the analytical balance and close it with a piece of aluminum wire. So this is intended to be a watertight seal, but not an airtight seal. So the gas is still able to escape from our Erlenmeyer flask. In order to make it even more watertight, we're going to add a second larger piece of aluminum foil called the bonnet and attach that with a rubber band. Now that it is prepared, this can go into the hot water bath. This unknown is going to go into the water bath that we've made. We're adding a piece of aluminum foil to help contain some of the heat. And we're adding our thermometer into the flask. We are now going to heat it until all of the liquid, until we no longer see any liquid left in our Erlenmeyer flask. All right, now once we've heated it until the liquid has turned completely into gas, we can tell that by wiggling the flask a little bit, and we don't see any liquid wiggling in the flask. We're going to record the temperature by recording it in the water. We pull it up, we record the vapor above the water, and we're going to average those two temperatures for the final temperature of the flask. We're going to carefully remove our flask and shut our water off. So you shouldn't see any liquid, but as it cools, you'll start to see small amounts of liquid forming in the flask again, and that's the vapor cooling back into a liquid. We're going to move over to the bench, and once it is cool enough that you can handle it safely, you're going to want to remove as much of the liquid vapor as possible. We're going to take the bonnet off and dry around the aluminum foil inside the bonnet before we weigh it again on the balance. Once our flask is cool, we have a little bit of liquid in it. We're going to use the exact same balance that we used before to make sure that our mass is as accurate as possible. Our balance reads 0 grams before we add our flask. Set it in there and close the doors to record the final mass, including the small amount of liquid that completely fills the Erlenmeyer flask. You are now going to repeat the entire procedure again with the second portion of your unknown, following the exact same procedure.